Okay, so lesson 8.5 is about line plots. Now there's a little difference in this one. Excuse me. There's a little difference in this one because if you notice, the fractions are different, so we have to change some of them before we put them on our line plot. So the story says, the Right Stuff, a stationery store, sells a variety of different size envelopes for business and personal correspondence. The heights and lengths of the envelopes are given in the tables below. All measurements are in inches. So they tell you the height and the length of the business envelopes and then the personal envelopes. So like if you were going to send a grandma a card or something that is just to a friend. Now these would be for business envelopes, so like paying bills and things like that. So if you notice, we have halves, eighths, and fourths for our denominators. So if you look at the chart down below, here's 3 and here's 4. You have to see what they, how many pieces they split each whole into. So from between 3 and 4, we have 1, 2, 3, 4, 5, 6, 7, 8. So they actually cut them into eighths. So we are going to be marking as eighths. So everything that's marked as eighths as a denominator, it's going to be really easy to put on our line plot. If it's not marked as eighths, then you have to change it to an equivalent fraction to figure out where it would go. So like 1/2. 1/2 is equal to how many eighths? Well, remember to do equivalent fractions. We haven't done this for a while. But to do equivalent fractions, so here we have 1/2 and we want it to equal eighths. So to make an equivalent fraction, we multiply 2 times something to get a denominator of 8, and that would be 4. Well, if we take the denominator times 4, we have to take the numerator times 4 also, because 4/4 is the same as 1 whole. So it's not going to change the value of the fraction because you're just taking it by a whole, but you're changing the numerator and the denominator. So 1/2 is equal to 4/8. So 3 and 4/8 is where that one would be marked right there. Okay, so then we have 3 and 5/8, 3 and 5/8, and 3 and 5/8 here. So we have 3 of those. The next one we have 3 and 3/4. So again, we have to change 3/4 to eighths, and we're still fourths, or changing 4 into 8. This time we're going to have to multiply times 2. So 4 times 2 is 8. 3 times 2 is going to be 6. So this one is equal to 3 and 6/8. So here's 4/8, 5/8, 6/8 right here. So that one goes there. You have to do the same thing with 1/4 to change into eighths. Multiply times 2. So after you have all those figured out, then you can go ahead and plot them on your line plot. So this is what your line plot would look like if you plotted all those heights on your number line down here. So then we have to come up with a title. And so this has been a struggle for 4th grade. This year is coming up with titles for line plots. So remember, you've got to think about what is the line plot showing, okay? So again, you can read through the little story and figure out, say, so what are we showing in our line plot? Well, what they wanted you to do was down here, they tell you that the Right Stuff has all these different envelopes and they are putting them in a line plot, or they're measuring them so they know what sizes they have available. And then they want you to plot the heights below. So this heights definitely is going to be there somewhere because that is what we're showing. And we also want to say envelopes because that's the heights of the envelopes. And then maybe we should say something about Right Stuff because it's a stationery store. So for a title, you could say heights of envelopes at Right Stuff. okay? And then underneath, you have to have a label for the X's. What do the X's mean? Well, remember we have to show what it is we're measuring and what label we used. So the height is what we were measuring. And then we have to tell what measurement it is. And then up here it tells us it's in inches. So heights in inches. And you could even say heights to 1/8 of an inch. Okay, but heights in inches is fine. So this is what you would have for your labels and your numbers, your X's. So I'm going to go ahead and screenshot that, because then we have some questions that we're going to go to. So I'm going to do a split screen here so I can show you the line plot at the same time that we're looking at the questions. So here is my line plot that I did previously, and then my questions are over here. So it says, what is the largest envelope height sold? Okay, so we're not looking at the number of X's, we're looking at which envelope is the biggest. What's the largest size envelope they have? Well, they have one or two different envelopes that are 6 inches. So the largest one would be a 6-inch envelope. So that's what would go here. And what's the smallest envelope height sold? Well, if you look at your chart again, there's a 3 on our number line, but did we have any envelopes that were 3? No, so the smallest size was 3.5. So remember, just because the number is on your number line, if there's no X's, that means you have nothing for that number. So you have to look at the first piece of data that you have. Which envelope height is stocked the most by the right stuff? So which envelope did they have the most of is what they are trying to say there. And it's this one right here. There's 3 of those, and there's only 2 for several of the others. So 3 1/2 would be the same as 3 4/8. So the next one would be 3 5/8. So they stock more 3 5/8 envelopes than anything else. And then it wants to know what's the difference between the largest and the smallest heights. So we had the largest was 6 and the smallest was 3.5. And this is one of those problems where right now we have 6 and 0 halves up here. And we don't want to do 0 halves minus 1/2. So we have to borrow a whole, and we're going to change that whole into halves. Well, a whole is equal to 2 halves. So now I have 2 halves up here. So 2 halves minus 1/2 is 1/2, and 5 minus 3 is 2. So the difference between the longest envelope and the smallest envelope is 2.5. Now you could also figure that out by looking at the line plot. So if you go from 3.5, here's 1/2, here's 1, 1.5, 2, and 2 1/2, or 2 4/8. So you could also say 2 4/8. So you could use this as kind of a number line to get your answer there too. In the United States, the most popular business envelope is 4 1/8 by 9 1/2. It is called the standard number 10 envelope. How many of the envelopes sold at the right stuff have a height larger than 4 1/8 inches? So here is 4 1/8 inches would be clear back here. And you want to see how many envelopes do they have that are bigger than that. So you'd have to count every X that's bigger than that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 would be your answer for that one. And then how many of the envelopes sold have a height smaller than 4 1/8? So then you're going to count the rest of them. But we are not going to count this one right here, okay? Because smaller than means it does not include this one. So 1, 2, 3, 4, 5, 6, 7, 8. There are 8 envelopes that are smaller. How much larger is the height of the number 10 envelope than the smallest one sold? So the number 10 envelope is, let's see, is 4 1/8. No, sorry, 9.5. And the smallest one that they have is a 3.5. So 9.5 minus 3.5 would be 6 inches. And how much smaller is the height of the 10 of the number 10 envelope than the largest one sold? So the largest one that we have is a 6, and what they had was a 4 1/8. So 6, let's see. Okay, so 6 minus 4 1/8. I read that again to make sure I was reading it correctly. Okay, so 6 is the same as 6 0/8. So we have to have something here to subtract our 1/8 from. So we're going to change this into 5 wholes, and then that whole we're going to change into 8/8. So we have 5 8/8 minus 4 1/8. So 8/8 and 1/8, 8/8 minus 1/8 is 7/8, and 5 minus 4 is 1. So 1 and 7/8 is the difference between the height of the number 10 envelope and the largest one that they sell at the Right Stuff. Okay, so I will be posting the home link that goes along with this. There's another line plot that you can do that's a really good practice. And then I will post the answers to the home link. So thanks for watching. Have a great day.